So now I call for the last presentation, Professor Ham. Please come on the stage. Thank you very much.
Assalamu alaikum. Good afternoon, everybody. It is my pleasure to present some of the work that we have been doing at the University of Portsmouth, UK. I'm Home Dhaka. I'm Professor of Mechanical Engineering, and I also lead a research group called Advanced Polymers and Composites. So the title of our talk is Development of PCL Jet Palm Fiber Bio-Composite for Sustainable Packaging Applications. And we are looking at two different methods to produce the material. I put my stopwatch. Hope that works. It's a quick outline, so I'm not going to go too much. I'll try to be as quick as possible due to time constraint. So we are trying to look on dry blending and melt blending and comparing them in terms of performance for packaging applications. So we have some experimental work and some results and discussion. As we can see, packaging materials constitutes a huge amount of polymers, almost 46% of them. And then if you look at the diagram on the right-hand side, most of them are in linear, so they are not recycled. So there's a big challenge as well as opportunity to work in this field. So you can see the jet palm fiber-based biocomposite can be used in different packaging applications. So our focus has been more on towards the right-hand side, more packaging tray or packaging film materials. So we can see here two types of process that can be used or have been used currently, melt blending and dry blending. So here we are trying to compare these two techniques and see both techniques in terms of performance as well as environmental aspect or energy consumption. Well, you can see here the time and cost, energy, process, and the mixing is coming from melt blending. That's great, but the energy is a big concern. If you go to dry blending, obviously the blending itself is a challenge. Mixing materials is a big challenge. So our research question is, mechanical properties of melt and dry blending biocomposite, is there any difference or not? Where is it possible to improve fiber polymer mixing in a dry blending process? So this is two research questions that we have been trying to find the solution. Well, here we have used PCL as a matrix material, and then we have used jet palm fiber as a reinforcement material. So, well, I don't need to go to say why PCL. There are so many good attributes about PCL. Due to time constraint, I have to move very fast. I'm sure you'll all appreciate because we'll be waiting for lunch. So in experimental work, we have PCL. That was the material that we obtained with different melt flow and so on, and then jet palm fiber coming from Saudi Arabia, leaf sheath, and thanks goes to Dr. Fahad Al-Mansour for bringing this material to Portsmouth, or sending this material to Portsmouth. And then obviously we have approach one, polymer as pellet and fiber as grinded powder. So that's what we have been doing in this particular work, which I have reported here. And then another work is where we have grinded fiber as well as the polymer, PCL. So yeah, approach 2, that is what we are trying to do. So let me first share the result obtained from approach 1, and then I'll go to approach 2. You can see PCL pellet and jet palm fiber. PCL is made of powder and jet palm fiber. Then we use this cryogenic grinder to grind them. And then obviously dry blending. Then we use compression molding using 120-degree 5 megapascal pressure, compaction pressure 10 minutes, and then normal air cooling, and biocomposite panel of that dimension, and different concentrations of jet palm fiber from 2.5 to 10 weight percentage. And then we look tensile properties as well as dynamic mechanical analysis, and then that's what I would like to present here. And then we also have done morphological analysis, the fracture surface of the specimens using SEM, and then obviously tensile testing. We also look weightability using contact angle measurement. And then we also have used DSC and TTA just to measure thermal stability. Right, in tensile test result, as you can see here, dead palm concentration has not improved tensile strength. Rather, it has decreased. But as far as the modulus is concerned, as you increase the volume, weight percent of concentration, it has improved. So you can see here a filler effect on modulus. However, the strength has not been increased. And then, so similar mechanical properties were reported in literature too. So slightly higher tensile strength in their literature, and then the modulus increased, but perhaps because of the grade of PCL used, we had slight different results obtained. So another work they have in the reference 3, I'll show that reference in the end, thermal degradation and some other properties produced by extruser. So this is just quick comparison of literature, and here we use contact angle measurement to see the weightability. As you can see, increase in dead palm fiber has increased the weightability or decreased the contact angle. So obviously hydrophilicity of dead palm fiber would increase the weightability, which is good. So then we looked on DSC result, the heating and cooling cycle, as you can see with different percentage of dead palm fiber. The temperature has changed, and you can see here 100% PCL, melting temperature 58, and then with 2.5, 59, and 57. So it's slightly decreasing in terms of temperature, and crystallinity has also been decreased because of the inclusion of dead palm fiber. In terms of peak temperature and then onset of degradation, you can see the temperature has increased with the inclusion of dead palm fiber. And then crystallinity time has also increased. So that with that, you can see the shift in peak of this result. So the fiber has influenced crystallinity process, and crystallinity decrease with the increase of fiber contents. So on TGA, we have some results. Fiber started to degrade earlier than PCL. More the dead palm fiber contents created a more ash percentage. So this is another finding that we have got here. From DMA results, the storage modulus and loss modulus has been increased with the dead palm fiber inclusion. So this is the approach 2 that we are currently working, and that is both material being grinded, so PCL as well as dead palm fiber. So the conclusion is that dry blending fiber polymer and of dead palm fiber PCL composite manufacturing could be a potential alternative to melt blending process, which will enhance environmental performance. It will decrease energy consumption, which you can expect in melt blending process, if we can prove that dry blending is better. But we are still working on that. So it's a very comparable mechanical properties compared to available literature. So yes, and then also the on PCL, adding dead palm fiber has improved thermal mechanical performance, which is really good. And so we think that it can be used as a potentially sustainable packaging application, dead palm fiber blended in PCL. So so we need to obviously get some improved mechanical performance and optimize the manufacturing parameters for the dry blending. Approach 2.1 is continuing. And then, so we want to further work on the 3D printed material from this work. So these are some of the findings that we have obtained from this work. I want to see my time. Yes, 9 minutes, 43 seconds.
Very good.
Thank you very much, Professor Ham. Thank you.
We need a speaker like you know, to finish on the early.
Thank you very much. So we can take more questions, maybe. Okay, any question?
Yeah, thank you so much for such a quick presentation. Regarding the mechanical properties, so this is the main limitation.
Yeah.
So what do you think in future, that how do you improve?
Yeah, we can do some treatment on jet form fiber and enhance the compatibility between fiber and matrix, and then enhance the performance. So that is one way we're thinking. Maybe the parameters can also influence the mechanical performance. So the compaction pressure that we have currently used, and the temperature we have used, and the dwell time we have used can be altered, and see what is the effect of that on properties. Because this is ongoing work. This is a very preliminary result that we have obtained. And one of our PhD students who was appointed October 2nd, he's working in this field. So in the maybe next BioPalma presentation, I'll bring a lot of good results, I hope.
Yeah. Thank you.
Any more questions? No more questions? Okay, thank you very much, Professor. Thank you.
Thank you again so much for this opportunity and for your attention.
Thanks.
Hello. So we have the certificate for the presenter. So first of all, I call the Prof. Muhammad Munir. If anybody want to take photo. Saeed Al-Haw. Saeed, come. Abdul Rasul Al-Umran is not there. Mukarram Zubair. Absorption. We recently done on lignin, Prof. Home Decal. Okay, last I call the session chair to come on the stage. So now the session is finished, so please enjoy the lunch, and we are going to see you tomorrow, inshallah.